Okay, this video is going to cover a very important operation on signals which we use a lot. It's time shifting. Time shifting of signals is used in convolution. It's used in considering signals with delays. It's used quite often in developing, say, Fourier or Laplace, well, typically Fourier transforms of complex signals from simpler signals. So the immediate application that we'll have for time shifting is my mind just went blank, is determining whether or not a system is time invariant. So to begin with, suppose that we have a signal which we'll call x of t, and I'll draw draw some axes here. In fact, here we'll actually do x of t in a different color so that it looks nice. We'll make x of t bright green. And let's suppose that we'll do something that looks sinusoidal here, because I seem to be having a good sinusoid drawing day. And we'll suppose that this, just to make it clear what's going on here, that this signal is 0 for values of t less than 0. So it wiggles when t is greater than 0. It's 0 for values of t less than 0. Okay. And we're going to create another signal, y of t, which is equal to our x of t shifted by, let's arbitrarily say, a value of 1. Okay. And in order to have this make sense, I guess I'd better put some, we'll call this pi, we'll call this 2 pi, which means that 1 is right about here, minus 1 is right about here, and so on. Okay. So my claim, which we'll verify in just a minute, is that by taking x of t minus 1, we're actually, by setting y equal to x of t minus 1, we're actually going to shift x to the right by 1 unit. So let's see if that actually is true. Let's draw a second set of axes here. And let's see what happens if we start plugging in different values of t and figuring out y is for those different values of t. So 1 seems like a good one to start with. So we have a value of t is equal to 1. Okay. So when t is equal to 1, I go up here and I would put in 1 for t. I then have minus 1 because that's what I'm doing here. So that's equal to 0. So y of 1, again t is equal to 1, y of 1 is x of 0. X of 0 is this point right here. So basically y of 1 is the same as x of 0. And in fact, we'll actually build a table over here so we can keep track of these values. Y of 1 is the same as x of 0. Okay, so far so good. So let's look at 2. Okay, y of 2 is going to be, okay, so if I now have a value of 2, let's get rid of these numbers. Okay, so with a value of 2 for t, I have 2 minus 1. So y of 2 is x of 1. Okay, x of 1 is this value here. So y of 2 is going to be that same value down here. So basically I've gone down here. And so we could keep repeating this process until we discovered, and hopefully it's beginning to make sense now, that y of t, if I say y of t is x of t minus 1, then what I'm doing is I'm taking x and shifting it to the right by 1 unit to get y of t. And so when I go through and draw this all out, I get something that looks like this. Oh, here, we'll do this in red. Okay, so red, y of t looks something like this, where my art here is not very good today. So that's pi, that's 2 pi. And if I've drawn this correctly, what I've done is I've taken x of t and shifted it 1 unit to the right. Okay, and that's what we got when this term was negative. So we're subtracting 1. Subtracting 1 corresponds to shifting 1 to the right. Okay, so hopefully that made sense. Let's see what happens. We'll get rid of all this stuff, and we'll get rid of all this stuff. We'll tidy this up just a little bit. Okay, so let's see what happens if I now say y of t is equal to x of t plus 1. Okay, well, we're going to go through this one faster than we did the last one. We draw our axes, and we want to find y of 0. Okay, to get y of 0, I've set t equal to 0 here, so this is 0 plus 1. So y of 0 is equal to x of 0 plus 1. Okay, so in this case, y of 0 is x of 1. So now I get this guy coming down this way. Okay. Similarly, you can show y of 1. Just got a y of 1 is x of 2, and so on. And so when you go through this whole exercise, you will get something that looks like this. Okay, where now you've taken the whole x of t and you've shifted it 1 unit to the left. Okay, so in this case, a plus 1 shifts it 1 unit to the left. So the way you usually see this sort of thing written, well, not usually, but often, sometimes you'll actually be shifting by a given amount, but sometimes you'll have something like this, x of t minus tau, where tau is another variable. So the idea here is that instead of putting in an actual number, say this 1, we've put in a variable that shows the delay. And so this is this signal would be the original signal x of t shifted to the right by tau units, whatever tau happens to be. And in convolution, it turns out that tau is a dummy variable of integration, and you get all sorts of interesting things happening. But anyway, that's the operation of time shifting. Hopefully this makes sense.